8 a.m. here, so you'll see that the day's getting slightly better as we go along, and hopefully the color of my face will improve and I don't look like an extra in the Addams Family. You know?
Look at me. I'm in this flush with this light here.
Yeah. Cool. Well, look, I think we're live, so let's make a start in. So if I can do a little introduction. So hello, everybody attending Bash. If this is your first time, you're very welcome. This is not our normal format. Normally we'd have 3 talks of half an hour each, plus Q&A. But this is a special event because we've managed to get Josh Long's time for 2 hours, and we very much intend to make the most of it. So Josh, the plan is to scoop your brain out. Just before we start in, just thinking if there's, there are a few announcements I would love to make, but they're premature. So we're hoping to get a couple of related events in before the end of the year, but we're not quite ready to announce yet. But there will be great things hopefully announced in the next week or two. So let's just move on to the main event. Josh, I think anybody who doesn't know who you are would just get sent back to the mail room. But in the off chance anybody doesn't, can you just introduce yourself?
Well, hello, my name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Java champion, a Kotlin developer, a Google Kotlin developer expert, etc.
Excellent. And one thing I've always wanted to ask you,
Sure.
How do you do it? Because I mean, I've done the plane, trains and automobiles thing for 20 years, but that's only around the UK and Europe and maybe a quick trip to the States every 6 weeks or so. And that's barely reversing out of the garage by your standards. I mean, you're constantly circling the earth apart from the current pandemic. So I've always wanted to ask, how do you survive? How do you do it?
You know, I don't know. And looking back, I sort of wonder if I'd be able to get, will I be able to get back in that swing? I don't know. I did 650,000 miles last year, so that's more than 1 million kilometers in 2019. And you don't do it for the travel, that's for sure.
Yeah.
You're interested in being a tourist. That's just not the reason you're there. It's the people, it's the communities, it's the conversations I get to have because I've put my foot on terra firma somewhere interesting, and there's people there. There's interesting people. I don't know. The motivation is different, so maybe that's what makes it easier for me.
Yeah, cool. I was going to say, you're not having any withdrawal symptoms. You don't need somebody to like squish you into a corner and sprinkle peanut dust over your head or something like that. Isn't
that weird? I've become so synonymous with travel. People, even now, people are like, oh, they haven't talked to me in a while. Like, how you doing? You must be weird, right? I'm like, well, yeah. They're like, do you miss traveling? I was like, well. Now that you mentioned it, thanks a lot, you insensitive Claude. No, I'm just kidding. I don't know. It's very strange to think that there's all these points and miles accumulated in my accounts, and I have status, top level status on everything, and I can't spend a lick of it. There's nowhere to go and know what I want to. I just want to stay here and avoid the plague. I've got asthma, so I'm particularly sensitive to the existential threat implied by the virus, So it's just weird. I'm glad they're going to prolong the status there, so next year. Yeah. But people ask about it, and I'm like, I don't really miss it, and I quite like a routine, whatever that is for me. It's nice to have a routine again, and the miracle of teleconferencing. It's been nice. I don't know. What about you? Do you miss it? I mean, it must have been. What's it like to get off the elevator?
Yeah, no, it's really weird. I mean, doing all the virtual training. I mean, it's like you say, you miss actually seeing people in the classroom and having interactions and just going to other locations and so on. But at the same time, it's been incredibly good for my health because I'm actually averaging more than 7 hours sleep a night. And you don't have that worry. The way whenever you're taking a big flight in 24 to 48 hours and you're just a little bit more careful about what you order in the restaurant, or you have a sudden paranoia check of where your passport is, and that's no longer there. And I think that's a good thing.
I lived with that constant, like a Minuteman, right? Like I never had a luggage completely unpacked, because it was always just in flux. There's always going to be something there. I just needed to top it off, basically. Yeah. Life isn't that good if you have to talk about your luggage as topping it off, right? Just gonna add a little bit of clothes to the top, and I gotta go. And then for me, it was very interesting to have that sort of like, where am I going to go next? Dread, and it motivates you to take your brief moments at home, to look at it from a different light. It's just very different, and I miss that. But on the other hand, I don't know if anybody knows, but I had I used to get sick a lot. I have asthma, right? So it takes a toll, right? Even me, I sleep like a baby on planes, and for the last 5 years, I've been lucky enough, in particular, that my company's been indulgent of occasional business class travel for certain use cases and so whatever. But I could sleep sitting up before. I've been doing this for a decade, right? So I've always been able to sleep on planes, but it's just not normal sleep.
Yes,
you get weird things that happen. Like if you don't get normal sleep for long enough stretches, that's been linked to all sorts of weird stuff. For me, it was I had weakened immune system, so I'd be in a plane, flying sardine can with how many goodness knows how many other people. And I always got sick, and so I always traveled with a little pharmacy of drugs, like a few antibiotics for intestinal distress versus respiratory distress, and medicine. I'd call my doctor up and I say, "Doc, I'm having A, B, and C," and he says, "Do you have the whatever I gave you?" And I'm like, "Yeah, okay." And he'll talk me through it while I'm in some far-flung corner of the planet. I'm just like, I haven't been sick since March. Truly, I haven't. I just recently, the last few days, it's starting to rain here in San Francisco, and I've just recently had to blow my nose. But even that isn't a chest infection or anything. It's just blowing my nose because it's a little cold or a little drafty at night. That's it.
No, absolutely. No, I know what you mean. I get migraines, so I always travel with a little pack of things, just in case the worst comes to the worst. And you know how it is. You have a tough week and you come back and you have what I like to call Friday friendliness fatigue, which is when you want to come home and just stare at the wall and not talk to anybody, and everybody's saying, "What would you like to do over the weekend?" And I'm like, just sit in a corner,
Can we just go, please? But I was the opposite. My partner, I'd come home and I'm like, "Come on, babe, we're going out. I don't want to sit. I don't want to stay home. I want to go." Like, I pay a small fortune to live here in San Francisco, and I always thought, like, my partner, she's been living in San Francisco with me for the last 4+ years. I've been living here for 8 years, but she's already seen well more of it than I have. Just for the fact that I'm constantly ping-ponging all around the planet. She's much more acquainted with the city. I feel like a stranger in my own home.
I know just what you mean. I get the same thing.
Anyway,
listen, I think it's gone 10 past, so let us make a start in. So without further ado, we'll switch over to yourself. I'll drop in every so often to ask questions, and I think we'll have a comfort break in the middle for anybody who rushed through their pot of coffee and isn't feeling like staying in the same place for 2 hours. But without further ado, I shall hand over.
Alrighty, I appreciate it. Thank you ever so much. Let's see here. So I suspect I'll just hide that. Whoop. That keyboard I used to use is no longer working. Let's see. Preview. Well, this is odd. My they updated the software. That's what they did. Something's a foul here. How do I show this presentation? Shift W. Okay. There we go. Okay, thank you everybody so much for coming. I appreciate your time. I appreciate you being here. I appreciate that you have other places you could be, other beds you could still be in, lots of things you could be doing, and yet you're here hanging out with us. For me, it's just after midnight in San Francisco here in the United States. I appreciate that it's getting on past 8 o'clock over there where you are. So either way, really appreciate you being here. It's super cool to be able to hang out in the dead of night with similarly inclined people, and I appreciate that. So first things first, my name is Josh Long. I work on the Spring team. I'm a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. And I want you to take note of this code, right? The code here is github.com, Josh Long, Reactive Revolution. And you can find all the sort of details, all the detailed code that we're going to look at here today. I might spice it up a little bit, and I'll point out where you can find an alternative repository if if that should be the case, because I think we've got a couple hours, so maybe I'll throw in a lot of other stuff. Either way, work on the Spring team. I used to travel. That was a thing. I have some training videos. These are on Safari. I've got a book I wrote a few years ago called Cloud Native Java. I have a podcast I do every Friday called The Beautiful Podcast, which is just me talking to people that are smarter than I am about this, that, and the rest. I mean, just all sorts of stuff. I think you might like it. Check it out. And I have a roundup I do every Tuesday. That would have been yesterday for both of us, but for me, only by a few minutes, where I recap all the news that's fit to reprint in the Spring ecosystem and the Java and adjacent ecosystems, Agile, microservices, all that kind of stuff. And of course, I have a screencast series that I do every Wednesday, which is just me at a keyboard, in deep diving on particular topics that interest me. And I also have a book that I wrote that I've just published a month or two ago. When was Spring one? I guess that would have been September, so 2 months ago, called Reactive Spring. And this book is all about how to build applications that take advantage of reactive programming. And that's what we're going to talk about today. So who knows? Maybe you don't need to buy the book. I could see that being true. So let's talk about reactive programming. Now, I want to contextualize reactive programming. I want to talk about the big picture here. Why do we care about reactive programming? Well, obviously, and by the by, friends, just tangent, the slides aren't going to advance very much for the next few minutes. I'm just going to talk to you. You can still see me. Don't worry if you don't see the slides moving, because clearly I'm far away from the slides, okay? Sometimes people get ill at ease when they can't see slides advancing. We're just talking. So let's consider the big picture here. Why do we care about reactive programming? Well, I always tie everything I can, whenever I can, to the bigger picture, the larger business outcome. Why do we care? Obviously, in the last 10 plus 20 years, right, we've seen this sort of this new insight that agility is important, that going faster is important, that organizations are starting to understand that they're starting to understand the existential threat that's implied by other organizations that are able to iterate faster. They're able to learn more quickly. And so this need for speed, this focus on delivering software into production more quickly, more capably, again, it's not a new idea. We've certainly seen a lot of amazing things in the last 20 years that owe ultimately to this new obsession, this new goal, right? Think about it. Test-driven development, continuous delivery, continuous integration, microservices, cloud computing, agile and agile methodologies thereof. All these things are all about fast feedback. That's why we care about agility. When we say we care about agility, what we're talking about is being able to try something, see the result, validate it, or refine it, and then try again in a loop as quickly as possible, right? This is mirrored by the military, right? If you talk about the OODA loop, OODA, right? Adrian Cockcroft famously talked about this OODA loop, the observe, orient, decide, and act loop. And it's this idea that in the theater of war, if you're in a dogfight with other fighter jets and your plane is sufficiently fast or more agile, more nimble, then you have a better chance, a much better chance of succeeding than the otherwise more impressively armed fight in the theater of war, right? So basically, if you're a fast plane, you can do better than the big, brawny, muscly plane. That matters because it gives the pilot a chance to see something, respond quickly to it, and then make another decision and try that out, right? So same thing for software. This idea of going quickly is very, very important. And so what happens when we embrace that fast feedback loop, right? What we're truly doing is embracing the idea that we want to learn quickly. We want to optimize for learning, okay? So this is super important. I care about learning. I care about building a learning organization. So when organizations pursue this, a lot of things just sort of naturally fall out of that, and they make a lot more sense in the vein of I'm trying to learn quickly. I'm trying to refine quickly. Things that fall out of that include microservices, right? Because think about that. When you have a large code base and you decompose that large code base into small, singly focused, independently deployable, bounded contexts, what you're doing really is you're giving your organization, the chance to optimize for autonomy, right? And the reason we want autonomy is because it gives teams speed, and with that speed, we get back to that core idea, right? So what we're doing is we're embracing microservices because they allow us to take a large code base, which requires a lot of people, and to decompose it into a set of small code bases which have small numbers of people. The smaller the team, the easier it is for them to keep, to coordinate, to synchronize, to keep everybody apprised of what is happening, what the current state is, right? The less the cost of synchronization and coordination with other parts of the organization. So microservices are, they're sort of a hack on organizational efficiency. They're optimized for small teams working quickly and removing inventory or waste from the process, right? So you've heard about lean manufacturing and Toyota. They had this idea that a car that sat on the floor in the plant, this manufacturing plant, a car that has sat there sort of 80% finished or 99% finished is, if you have 100 of those and you have one finished car, from Toyota's perspective, it's much better to have one finished car that's ready to sell than it is to have 100 cars that are 99.9% finished, because they all represent waste. They all represent an investment from the organization that hasn't yet been recouped. That's lost potential. This one car can be sold. It's worth a positive number, whereas these others all represent loss. And so the same thing is true with software, right? If you have software sitting there gathering moss, then it's waste, it's inventory, it's inventory that needs to be moved. And so we want to go quickly. We want to have that in the organization. So microservices are a response to that. They're this idea that we can take a small team, remove the inventory, remove the lead time from one member of the team to another, right? So instead of having all the ops people over here and all the developers over there, now they're all focused on one feature. And then you got them co-located. So operations, product management, developers, security, whatever, all of them co-located in one team. There's no inventory, no lead time. Coordination goes down to nothing, right? The cost of it, that is. And then now, as long as you're focused on this one feature, that's a natural sort of boundary for your microservice or the system of microservices that you care about. Other teams have their own sort of co-located teams, and that allows them to go quickly as well. Google talks about this. They said, when they asked engineers at Google what they've most valued in their ability to succeed, they cited personal security or personal safety, the idea that they can make mistakes, iterate quickly, and move forward without being beholden to other parts of the organization. Basically, autonomy, right? So that is very, very important. Mel Conway, he understood this as well. He talked about the idea that organizations are a mirror image of the communication patterns that they have, right? So if different teams in an organization are dysfunctional, that'll be reflected in the software that these teams build. So the trick is to create small teams that aren't dysfunctional, that have one focus, and they're very clear about that focus, right? That way, there's no issues and there's no problems. This is a sort of reverse Conway maneuver in effect. So all that big sort of heady stuff, I hope you appreciate that, because that's really important to consider. What does that do? What does that have to do with reactive programming? Well, quite simply, when you move to microservices, when you move to this world where you're trying to build lots of small distributed services, naturally, new problems arise. And the question is, are they worth addressing? Is the cost, more prohibitive is the cure more prohibitive than the disease? And my answer is, of course, it doesn't have to be. Right? It doesn't have to be complicated or painful to build distributed services. Yes, there are the inherent risks and volatility that building a distributed system implies, but through reactive APIs and through patterns and primitives for building cloud native applications, which I frequently talk about when I talk about cloud native Java and in my last book and so on, through these different approaches, you can build distributed systems with more ease. Reactive programming in particular is, I think, a huge windfall. It's a huge gain for organizations without too much of a learning curve. It's not too big of a thing to take on, because once you learn it, it actually allows you to forget other things. It actually makes it so you can start doing things that you couldn't have done at all or with nearly so much ease before, right? So reactive APIs solve three problems. The first is, how can I more efficiently, more safely reuse threads on a given JVM? Now, of course, this is the least interesting reason to use reactive APIs, but it's very interesting, right? Obviously, Project Loom pretends some really exciting opportunities here, right? The idea that we can have so-called green threads or virtual threads, lightweight threads, it's been called variously. Really, really exciting, right? But even there, when you're using green threads, and you decide to use Java I/O input stream and output stream, you've got a problem, right? Java I/O input stream and output stream carry a lot of memory. They require a lot of memory, several kilobytes for each one. So you can't create, countless green threads and then do input and output using Java I/O input streams and output streams. You need to do asynchronous I/O. So you're going to get back to the same problem, which is, how do I write code that works in this asynchronous way, right? You're going to want to take advantage of something like Java and I/O. So reactive APIs give you a way to make better use of your threads by giving yourself a scheduler that then does a very good job of telling the runtime when you're not using a thread. That'll work very nicely with Project Loom in the future, right? There's a very nice interaction that's there. But in the meantime, you've already got reactive APIs that'll get you what you're looking for right now, instead of waiting another year for Java 17 to drop and then another how many odd years before everybody can use it. That's the first thing, right? Better resource efficiency, better ability to scale, and that matters, right? Of course it matters. Look at Cloud Foundry and Kubernetes. These are better bin packers. They allow you to take a lot of different containers and put them all in one machine, right? Virtual machines in general. The whole idea, the thing that we've all been chasing for all these years is, how can I make better resource efficiency? How can I get better data center efficiency? And so this is part of that, right? Now I can make my Java application more efficient. And by the way, this is a big deal. If you've ever built an application at scale where you do a lot of input and output, such as you would building microservices, you're going to see this. You're going to log into your data center, and it's not uncommon to log into a data center and take a look and see, oh, all my threads are in a wait state. I can't get any more requests into the machine, right? It's not accepting any new requests. They're all parked in a wait state, and the CPU is at like nothing. There's no CPU. Why is that, right? It's because all these threads are sitting there waiting for input and output to happen. And they're doing so using this Java I/O input stream interface. They're sitting there waiting for something to happen. And the result is that precious finite resource, the threads, aren't available to anybody else in the system to reuse. This is bad, right? It's really bad. And it's also, by the way, a great example of where having your application provide useful instrumentation that speaks beyond what the container platform can see at the low level in terms of CPU usage and RAM and so on, can be very useful, because a container orchestrator would look at that and go, oh, low CPU usage. This service is fine. Nothing's wrong with it. Keep it in rotation. When in fact, nobody's getting a response because they're all parked waiting for a thread to free up. Danger, right? So we want better bin packers. We want the ability to put more into our services and to have them do more with less money and so on. Reactive APIs give you that because it's much more efficient. The next thing that they give you is a consistent programming model, right? So increasingly, the kind of data that we have to deal with, it's becoming more interesting, more varied, right? Obviously, there's the sort of small bursts of data with which we're all familiar, right? Things that you could have done just fine without reactive programming. I want to get 10 records from a SQL database or something like that. I want to load up the profile for this user, right? That kind of thing, not a big deal. You could probably use JDBC template and servlets and so on and get that kind of thing. But the other kind of data that we have is something that's long-lived or asynchronous or latent or potentially unbounded. All of these use cases require a different programming model at the moment, presently, right? This is a problem, right? Because they're not different things. It's just that we don't have a nice way of describing time. When we talk about a Java collection, there's no way to say that there's data coming, but it's not here right now, right? So we need something that'll give us that. Java has a collection. That's not a good fit. We don't have, we can't really use, a completable future. That gives us one asynchronous thing. But suppose I have 5 asynchronous things, right? Then those completable futures don't work. So we need an API to help us describe this new kind of data, this potentially unbounded, potentially latent, potentially asynchronous kind of data. And this is very important, particularly in the microservices context, again, because we have a lot of this. We're doing more work coming across the wire, right? We see more work being done asynchronously. The third thing that Reactive APIs gives us is robustness. It gives us a programming model that allows us to embrace the reality of a distributed system, that things are going to fail ineluctably. They will fail. There's going to be volatility implied in service topology changes and things like that. And we need a programming model that allows us to respond to that. One way we can do that with reactive programming is to push back, basically, to say to a producer that might be producing too much too quick a rate that we can't handle anymore. We want to push back on the rate of production so we can avoid being overwhelmed. And also it does this, it supports this goal by having a number of different operators that allow us to express things like retries and rate limiting and so on. So we're going to see all these things in play, but reactive programming, amortized over all the possible uses of it, is a more consistent programming model, which means that we can now forget all these other disparate programming models. Instead of learning the Spring specific way to do Kafka and RabbitMQ and service and events and WebSockets and just 8 records from a SQL database, instead of having 10 different ways to describe these things, right? I have a stream of data coming from Kafka. I have a stream of data coming from a WebSocket. I have a stream of data coming from a 8-record results in my SQL database. Instead of having disparate APIs to describe all this, we just have one thing, the reactive stream. Reactive streams give us the ability to write code that responds better to failure and service volatility. Reactive streams give us the ability to write more resource-efficient code. These things are why we care about reactive APIs. And if you understand those, if you're kind of ready to sort of to move forward and see what it looks like, then I think we should, right? So let's go ahead and build some software to kind of take a look and see how these things play well together, okay? So what we're gonna do is we're gonna go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a service here. And in the service, we have, of course, the choice of Maven and Gradle, and then the choice of language. I'm satisfied with the defaults thus far. I think we might do well to look at Kotlin at some point in our time together today, but we don't have to. We should though. We got a couple hours. Why not? It's not really a out of the way thing. I can do it. Just occurred to me that now that we have 2 hours, we really could do it. Okay, so I'm satisfied with those defaults. I'm also very happy with the default version of Spring Boot as selected. Spring Boot 2.4 is the latest and greatest version of Spring Boot. It just dropped last week, so we are very lucky. We get to use this brand new version of Spring Boot, and there's a lot of really compelling features in this. Not least of all, including support for config maps, right? Kubernetes config maps for configuration, so we can mount what's called a config tree. Basically, when you use Kubernetes, you have a config map. You can tell the container to mount that config map as a directory, basically, with files that correspond to keys, and the contents of those files correspond to values, right? So that's a very interesting way to describe configuration. Spring Boot now natively understands that. You can point it to that. And Spring Boot also now has support for the native image support, right? So using GraalVM and ahead of time compilation, you can build native images using the Spring Boot Maven plugin much more naturally. So that's also really compelling as well. And then Spring Boot just continues the theme of what Spring Boot 2.3 did, right? It introduced features like Docker image generation. It introduced features like easy liveness and readiness probes for Kubernetes. It introduced features like graceful shutdown, so that when your pod in Kubernetes gets killed, when invariably it might get killed, whatever, then the application will stop accepting incoming traffic, and it'll drain off any existing in-flight requests and allow the sort of in-flight things to finish, and then it'll shut down, right? And you can configure that to work in tandem with your container orchestrator, so Kubernetes or whatever, right? So all these things are really, really nice. I like Spring Boot 2.4. That's neither here nor there, though. I don't want to get too far in the weeds on 2.40, but I do encourage you to take a look at it. There's a lot of good stuff. So, okay. And by the way, everything else we're going to talk about here doesn't require Spring Boot 2.4. It doesn't even really require 2.3. I mean, it's been possible to do almost everything we're going to look at today, I think, since 2.0, basically. Okay, so I'm going to call this service, and then we go down here, and we can see we've got a number of radio dials. We have the choice of packaging. Here we've got jar and war. Obviously, I'm a big fan of .jar. It makes a lot of sense for cloud native kind of deployments, and this is in keeping with my overarching philosophy of make jar, not war. So again, very happy with the default there. And then down there, before at the very end of our column here, we have 3 radio dials, 3 choices. Where at least it looks like we have 3 choices. We have really only two choices, my friends. The first choice that we have is Java 15. That's the current supported version of Java. A very good choice, and indeed the choice I'm going to make. There's also Java 11, which is the current long-term supported version of Java. It's fine, if a bit cowardly, right? You can use it, but I think you can do better. You should do better. Move to Java 15. If you're on a cloud platform, there's no reason not to use the latest and greatest, because you can conveyor belt onto the next version with impunity, right? It's not a deployment problem, right? And especially if you're using something like the Cloud Native Computing Foundation's Paketo build packs project, then you can easily just point your build pack at the application. It'll create a sensible file system containing your application and the JDK, and they can deploy, and then it'll create a container for you, and you can then deploy that to your cluster, right? That build pack understands how to upgrade your JDK to the latest version. So as long as you're using the latest version of the build pack, it'll always just give you the new stuff, right? So I like Java 15. Java 15, Java 11, okay choices. They're technically superior in every way. They're faster, more feature-filled, more syntax-full, more robust, more secure, more performant. Everything, just everything about them is just better. More, it's just more in every way. It's technically superior in every way. It's also morally superior in every way. Trust me, friends, you don't want to have that conversation when your kids find out that you're still using Java 8 in production. They're not going to appreciate it. You should do the right thing. Be the change you want to see in the world. Use Java 15, okay? So I'm going to leave that selected as is. And now I'm going to bring in some of the dependencies that we're going to use. We're going to bring in the reactive web support. We're going to bring in RSocket support. We're going to bring in Lombok support. We're going to bring in, do I want to try anything else? Let me see. We want to bring in Spring Cloud Stream. We want to bring in RabbitMQ. We want to bring in a database abstraction, some way to talk to a database. And so we have a number of different choices here. We can use any SQL database, right? There's a good many SQL database options out there, supported through the Reactive Relational Database Connectivity Abstraction, R2BC. This abstraction is a core SPI, and then as you can imagine, a whole sort of diaspora of implementations, right? Lots of different implementations that you can use to talk to, among others, Oracle, that's just been announced, Postgres, H2, MariaDB, MySQL, Microsoft SQL Server, SAP HANA, Google Cloud Spanner, Azure, Cosmos DB. I mean, just a bunch, right? It's harder to think of things that aren't supported, and I would have said Oracle, but again, like literally in the last 3 weeks, they announced that. So, you'll be hard pressed to find something that isn't supported. I would encourage you to try. So we're going to use R2BC, and we're going to use Postgres. Okay. That said, keep in mind that there's also good support for NoSQL options, right? There's a lot of different NoSQL options that are well supported out of the box, and I encourage you to take a look at those as well. And this is important to point out. These are reactive projects that are fundamentally built in a reactive way. They're not using input stream and output stream at the lowest levels to do communication with the databases themselves. They're using NIO, they're using asynchronous IO, and they're using APIs that allow them to jump off of a thread and return that thread to the thread pool while they're not being used. Or if they would only otherwise be used to sit there and wait for bytes, then these APIs are going to avoid that, right? So we have a lot of good APIs, but they are separate. This is a whole separate hierarchy of implementations compared to regular traditional Spring data as it would have existed, let's say, 4 years ago. So we have reactive R2BC, right? We have reactive Cosmos DB. We have Firestore, Google Cloud's Firestore and Spanner. We have reactive Cassandra, MongoDB, Redis, Neo4j, Couchbase, and Elasticsearch. And I think we just added another one really recently. Wasn't there another NoSQL implementation? I think there's a Cockroach DB one. I could be wrong. Either way, a lot of different implementations there. So we've got all that. I'm happy with the selections. I'm happy with Postgres. I'm happy with RabbitMQ, Spring Cloud Stream, Lombok, Spring Security. Did I bring in Spring Security? I didn't bring it. Okay, so security. And I think that'll do for now, isn't it? Should do. Whatever. We'll figure it out if I'm wrong. So I'm going to hit generate. And we'll go to the downloads directory. UAO service.zip. And the first thing I'm going to do is comment out some stuff because we don't need all of it just yet. So let's go to the service directory and make sure that as the clock just struck midnight not too long ago, there hasn't been a whole world of new updates to the snapshot dependencies upon which I'm depending. Turns out there have. Okay, good stuff. Happy? This is still thinking about it. Cool. All right, so it looks like it's working. We need to specify a JDK. There we are, Java 15. Go-away street cleaner. I'm on the 12th floor in a skyscraper here in San Francisco, and I've got the little vent open, and I can hear street noise like it's right next door, right off the street there. Okay, so there's my basic application, my basic class. Let's go to the build here and comment out, as I suggested, a few dependencies that we're not going to use just yet, or maybe not at all. I just added them for optionality, right? I might use them, but who knows? Who knows? Spring Security RSocket, messaging, binder, Spring Cloud Stream. Don't want any of that for the moment. R2BC, Postgres, good. JDBC, no need. Dependent, useless. Okay, so I've got my dependencies. And what I'm going to do is, as always, I'm going to write an application that writes data to the database. All right, so service application. And what I want to do is I want to build an application that, let's see, it's going to write data of type reservation to a SQL data store. That data store is running on my local machine, or if it's not, well, it will be. Start Postgres. Okay. There we are. And that database is going to have a table called a reservation. And I'm going to create an object to map to that table. But I need to create getters and setters and toString and equals and hash code and all that good stuff. So rather than write that out by hand, I can either use the Java 14 preview feature supporting records, or I can use Kotlin, Scala, Groovy, etc., and their respective syntax to make this just a lot simpler. So case classes in Scala, data classes in Kotlin, and so on. Okay. This is my basic object. I'm going to create a field here, ID, and another one called name. Voila. Okay. ID. Now, these already exist in my database. These are already in my backend database. I don't want to do anything more than just map this Java object to that database. In order to do the work of talking to the data store, though, I need a repository. Now, repository is, of course, this thing that handles the tedious, soul-annihilatingly boring read, write, update, and delete lifecycle management, right? The operations that we use to work with data. So these methods should, I expect, seem fairly straightforward if you've ever worked with something like Spring Data, or indeed just a repository pattern implementation somewhere, anywhere, right? Obviously, save all, find by ID, delete, count, fairly straightforward. What may not be so straightforward just yet are the parameter types, the return values and the parameter types. So the first type that we care about here is called a reactive stream publisher, and this comes from the org reactive streams project. This project, this package, this namespace, contains 4 interfaces and 1 concrete class. These 4 types and that 1 concrete class are the result of collaboration between the Spring team, between Lightbend, between the Eclipse Foundation, and between, of course, Netflix. And this was an effort to sort of to sketch out and define the common ground interfaces, the lowest common denominator interfaces for describing potentially latent, potentially unbounded, potentially asynchronous streams of data. The first type in this very, very, Spartan little namespace is a publisher. A publisher is a thing that publishes data asynchronously to a subscriber or to subscribers. You can have multiple. The subscriber, when it first subscribes, is given a subscription. We're going to talk about that in just a second, so let's put a pin in that. But this subscription is super important. The next thing that happens is if there are any records, 1 record, 2 records, 3 records, 5, 1,000, 1 trillion, 1 billion, infinite, whatever, those are passed here into the onNext method, one at a time. And when there are errors, if there are errors ineluctably, those are passed here in the onError callback. And then finally, when the publisher is trying to signal to the subscriber that the subscriber has reached the end of the stream of data, the onComplete method is called. Now, this reactive pipeline is fairly straightforward, right? Basic sort of asynchronous subscription to a stream. What's interesting here is the subscription. The subscription represents the connection between the producer and the consumer, the publisher and the subscriber. It's the thing that the subscriber uses to signal to the publisher that it wants more or less data. This is super important here, right? Here, the subscriber can use the subscription to say, I want 10 more records, please, or I want 100 more records, or whatever. If the subscriber should decide, for whatever reason, that it's just tired of this publisher, it's just had enough of it, it's been nothing but trouble, and it wants nothing more than to be done with it, it can call subscription.cancel, and that'll cancel the stream of data from the publisher. And that is basically most of what you need to know about the Reactive Stream spec. There's two other things in the package. The third one is a processor. Okay, a processor is just a bridge. It's a source and a sink. Where's my processor? There you go. It's a source and a sink, a publisher and a subscriber. And the other one is called a flow adapter. And the flow adapters convert these reactive streams types into their JDK equivalent. That's correct. So the common ground interfaces that we just reviewed, those have become so foundational that they have since been incorporated into the JDK as of Java 9. So if you want to use Java util concurrent flow.publisher or flow.subscriber or flow.subscription or flow.processor, you can, and you can adapt back and forth between the reactive streams types and the JDK types, right? So of those four interfaces and that flow adapters class, I really want to stress how important the subscription is. That ability for the subscriber to say to the publisher, hey, I'm done. I want nothing more of this, to push back. That's called flow control. And flow control is everywhere, right? Everywhere. If you've ever done any low-level TCP UDP programming, you've had to think about flow control. You've had to think about what happens when one node goes faster or slower than the other. This is flow control. Ditto for at the larger systems level, right? So forget about low-level packets over the wire. Think about high-level systems communication, right? Using a message bus, for example. Why have we for so long introduced message queues into our architecture? Why not just send it one to the other, right, directly? Well, of course, there's a lot of other reasons, but one of the biggest reasons, indeed, it's in the name in some cases, right, is the idea that we have a buffer, something that we can use to store and forward, right? We call it store and forward architecture. And here, this buffer has the effect of meaning that, of guaranteeing that the consumer of those records won't have to deal with all the records at once. They can drain the record, they can drain the message queue at the speed that's comfortable and workable for them, and no faster, right? And if we needed to scale up our processing speed, we could always add more processors, more consumers of that data. But we don't want the one consumer that we've got to be overwhelmed and to be, basically denial of service, right? So this is a very useful quality to have in a system, is this flow control that you get by enabling a message queue. Ditto for TCP UDP communication, where you think about flow control. Sometimes the marketing folks prevail, and you might hear the term back pressure. Back pressure is interchangeable in this case with flow control. It's super important in the Reactive Streams API. What's novel indeed about the Reactive Streams API is that we have surfaced this idea of flow control as a top-level construct, as a top-level concept. So we can use that, okay? We've got these types. If we need to use flow control, we can. I'll confess, you don't really often have to do that, but the point is the tools that you bring into your workflow will support working with back pressure and know to do the right thing there where appropriate, okay? And we'll talk about some of those later. Now, these types, as I said, are very, very Spartan. They're very foundational. And so while I like the Reactive Streams types, I think we can both agree there's room for specialization. And here's where Project Reactor steps in. Project Reactor is the reactive data flow library from the Spring team. It underpins all of our reactive support, but it builds on top of the Reactive Stream specification. So in the same way that Reactor supports reactive streams, so too does RxJava, so too does Vertex, so too does Akka streams, etc. And these things are interchangeable. So Spring works with any publisher, right? It doesn't care if you're returning a publisher that's coming from an Akka streams cluster versus or RxJava, whatever. So these types are interchangeable. They're compatible. There's a lot of portability here, but behind the scenes for our implementation of Spring, we use Reactor. We expect you're probably going to use Reactor, and Reactor has a lot of really nice features to it. Two of my favorite of which are the Mono. A Mono is a publisher. Ultimately, it's a publisher, but it provides a lot of operators, first of all. And second of all, it's a publisher that produces at most one value. So it has a semantic implication, right? It's like a completable future, but with back pressure, right? And so these operators, look at this, 4,771 lines of code. This is code, trust me, you don't want to write. It's no fun. It's tedious. It's boring. It's the worst kind of code. And it's hard to get right. It's really hard to get right. I guarantee you, you could spend years and years and years, and you'd only ever end up with something that's half as good and twice as buggy. So don't bother. We've also got Flux. Flux is yet another publisher. It's a reactive stream that produces a potentially unbounded amount of data. So 0 records, 1 record, 3 records, 3 trillion records, infinite records, etc. You would describe that with Flux. Now, why have these two specializations? Well, again, semantics. If somebody gives you a method and that method returns a mono of customer, mono, generic parameter customer, they're saying there's going to be either a customer or no customer, right? On the other hand, if somebody's showing you, if somebody's giving you a method that returns a publisher of customers, then there might be more than one, right? It might be like more appropriate to render that in a table, a grid or something like that, right? Because you're gonna have an overview page maybe for search results as opposed to the details for one particular record, which would be implied by something like mono of customer, okay? So the semantics are useful. But again, semantics plus all these amazing operators. Now, I've got an application. I've got my reactive streams repository there. Let's initialize our data here. So initializer. And this is just going to be a Spring Bean application ready event class public void begin. And all we're going to do is initialize our database. We're going to write some data to the database using our newly minted reservation repository. I need to inject that. And of course, I could do that by writing the code or alt entering my way into a constructor, but it's just nicer to use Lombok, and that synthesizes the getters and the setters for me, the constructor for me. And what I want to do now is I want to build a stream of names. And these are just going to be people, random arbitrary people in the Spring team. We've got Madura, she's legendary. We've got Yushin, she's amazing as well. We've got Olga, these are some of the smartest engineers in the world. And I'm just honored to work with him. We've got Stefan, he's amazing too. Oops, wrong accent. Good. We've got the good Dr. Sire. We've got, what is that? That's 3, 5. We need 3 more. So Violetta, she's legendary, of course. We've got Spencer and yours truly. Is that 8? I think that's 8. Looks to me. Yeah, good. So there's my reactive stream. I've just created my first reactive stream just from literal data, right? Like it's just a convenience factory method. And that gives me a string of a publisher of strings rather. And what I want to do is I want to visit each one of those. I want to say names.map name new reservation null name, and that'll give me a stream of reservations like so. Okay, reservations. And now I want to take each one of those reservations and write it to the database. So I want to say, okay, reservations.map r this.reservation repository .save r. Now, what is save going to do? Well, it's going to return a reactive type. It's going to return an asynchronous mono. So this mono is going to have a value, but I have to eventually subscribe to that mono to get the value. So what I have here is a mono of t for every single thing I save. And what does map do? Well, it accumulates all those return values into a container type. In this case, that container type is a flux. Well, what is the result of that but a flux of mono of t, which I don't want, right? So what I want to do, quite like the curve, is I want to flatten these inner reactive streams. And the way you do that is by using flat map, okay? So flat map, there you are, good stuff. Okay, so there's my, my saved records. And what I want to do now is, see that reflected in the database. Well, of course, if I ran this code as is, what do you think is going to happen? If you guess that nothing's going to happen, you're absolutely right? What we need to do is subscribe. This is a terminal function. If you think about it in terms of Java 8 terminal functions inside of the Java 8 Streams API, you need to turn on the water, to turn on the faucet to get the water flowing through the pipeline. We've defined the individual stages of the pipeline, but only here have we actually turned on the water to see that data flow through the pipeline. So, is this the way to write the code? Well, first of all, I wouldn't tease these things apart so needlessly, right? I only did that for our edification, but it's actually much more natural just to string these stages together thusly. Second of all, I want to delete everything in the repository before we run the code. So I'm going to delete all, but that's going to return a reactive type. It's going to return a mono of void. So then I want to say, after that's been done, then and only then do I want to save the data in the database. And then and only then do I want to find all the data in the database, like so. So I'll say subscribe, system out, print line, right? So what I'm doing is I'm using these operators to ensure that I get a deterministic behavior. I get step 1, step 2, step 3, right? As opposed to calling subscribe on each line and having that split up in a different thread and happening asynchronously and not having the ability to guarantee that one thing succeeds logically and chronologically the other, right? If I chain these things together using these operators, I get the result that I'm expecting. So there we go. Now I've got a cleaner slate here. It's going to start up. It's going to write the data to the database, but only after it's cleared out everything in the database, so we don't get duplicative records, on successive runs. Let's go ahead and restart this. It's complaining that I haven't specified to which SQL data store it should connect, and that's a fair point. That's a fair point. So Spring R2DBC URL R2DBC Postgres localhost orders. Okay, so there's my SQL data store URI. Username is orders. And obviously, friends, I'm storing this configuration in this property file. Don't ever do this. This is not what you would do in a production application, but to get off the ground, it's pretty convenient. You might want to consider using an environment variable, or better, something like the Spring Cloud config server or HashiCorp Vault integration or whatever. I mean, there's a lot of different options here for externalizing your configuration. So that done, let's restart the app. Okay, so we've got our data reflected here in the console. You can see our 8 records. It worked. There we are. We happy few, all 8 of us. We've been written, and we see the results reflecting new primary keys, which of course they got from the SQL data store. Life is good. Now we've got data in the database. The next natural thing to want to do is to create an HTTP endpoint, right? So let's do that here. And of course, we could do this by creating a REST controller, as always, right? So REST controller, reservation REST controller, like so. At get mapping / reservations, publisher of reservation, right? And just we can inject our reservation repository here.
Josh, can I just jump in for a second with a couple of questions?
Yep, we're gonna take a bio break here in just a few minutes, and then I'll happily answer questions before we do that.
Sure.
Sure. So I've got my repository here, and all I want to do is return the data thusly. And there's my endpoint, right? That's an HTTP endpoint using Spring MVC style controller annotations. And this is fairly straightforward, I should expect. But keep in mind, this is not Spring MVC. This is actually come on, I couldn't shut down the other one fast enough. This is actually a brand new web runtime called Spring Webflux. It's built from the ground up using Netty, right? And you can run it on top of a servlet API if you need to, but there is no servlet API by default. In the configuration we're using right here, there's no Tomcat, there's no Jetty, there's no Undertow, there's none of that, right? It's just a blazing fast reactive web runtime that you can use to build services at scale. I like the style as well, this REST controller style. This is particularly great if you have a bunch of endpoints that need to share similar endpoint, similar dependencies and configuration and whatever. In which case, amortized over the multiple methods that you might define, this makes a lot of sense. But is this syntax that I've just shown you, where we have a class and constructor and storage for fields and all that stuff, does that make a lot of sense if you just have one endpoint with one thing in it? Well, it doesn't feel very concise that way when you think about it, right? I've got my predicate here, which is the annotation, and then the body of the matcher or of the response that matches that predicate is here. So it's just 1, 2. Everything else feels a little extraneous, doesn't it? Maybe there's a exception to be had for the reference that we need to make this work. But nonetheless, this is not concise, right? So is there a better way? Well, I'm not sure if there's a better way, but there's certainly an alternative, and I quite like this style called the functional reactive style. It hails from Spring Framework 5 in 2017, and the idea is that you just create this functional matcher and describe the route. So I'm going to create a matcher for reservations. I'm going to inject the reservation repository. Okay, and I'll say new handler function. My job is to return a response. Whoops. Body. And I'll say reservation repository find all reservation.class. So there's my basic Lambda, and of course you can see the IDE giving me every chance to make this even more concise. And this can of course be whittled away, and then this needs not be so verbose. And there we are. There's my functional reactive HTTP handler. It's a builder API, so I can of course chain these invocations together. I can use a for loop or while loop to programmatically, dynamically add these matchers, these handlers as well, whereas obviously that would be quite a bit more difficult to do with annotations on a class. So this style is not exclusive to the other one. These things can be used in tandem. And if we start that up, we'll see localhost reservations. Voila, we have our 8 records talking to a SQL database. And at this point, friends, I can hear you going, so what, right? I could have read 8 records from a SQL database yesterday, right? I didn't need reactive programming to do that. And that's a fair point, but thus far, I haven't really been trying to persuade you so much of the superiority of reactive programming as I have the parity of it, right? The quality of it, the consistency of it. So let's remove any redundant and extraneous code. I don't need that. Obviously, this initializer is purely for the spectacle of learning how to use these APIs. That's just for our demo, friends. So let's get rid of that. That's not going into production. And there, what we've got left is, I think we can agree, trivial, right? Like I said, if you're using something like Java 14's preview features for records or case classes or data classes or whatever in these other languages, then it becomes a one-liner. Your repository is 1-2 lines. If you include this on the second line, that's fair. But also at this point, we're up to 3 lines of code, 4, 5, 6, 7, 8, 9 lines of code, right? So not a lot of code to get a application that talks to a SQL database, that talks to HTTP, and that does so in the most resource-efficient manner. I'm not asking you to write a lot more code to get the result. Quite the contrary. You'll find that this is as concise, if not more concise in some cases, because you have one kind of thing. You have publishers, right? This is really important to keep in mind. It's not a drop-in replacement, but it's not hard either, right? If I can do this, you can definitely do this. In the next hour, after we've taken a brief break and answered some questions, we're going to see these last 2 things that I talked to you about, right? We've got here a resource-efficient service. We've got here a reactive application. In the next hour, we're going to talk about building services and using reactive APIs to make it easier to do that in an efficient way, in a safe way, in a robust way. And we're also going to talk about, we're going to see how reactive APIs give us better scalability, okay? Let me restore my initializer here, and that done, I think we can take just an ever so brief, what did you call it so earlier, a comfort break?
Yes. Yes, comfort break, given how early it is in the morning.
Yeah. So do you want to read off some questions in the meantime while I figure out how to stop sharing my screen for the interim?
Yep, absolutely. So I think you're good with the screen sharing too. So a couple of questions, a kind of general one and then a specific one. So whenever the reactive approach, considered quite generally, is introduced, I mean, the most common criticism you hear is that, yes, it makes things that would be very hard or even impossible achievable. Yeah. But on the other hand, it can make simple things complex. So for example, I have a friend who's a fanatic about Node.js, and he always says, give me any Java code, and I'll make it better in Node.js. And then I show him one that takes a number, waits that number of seconds, and then writes a response. And he goes, okay, anything apart from that one, So to take a more springy example, if you're doing something like WebSockets, as I understand it, you get 2 reactive streams, going each way. But then if you want to tie them together, if you want to receive something, use it, and then send it back, you have to do that coordination yourself, and I know you address that in your book, but that's a good example of something that you would expect to be simple, but is actually non-trivial, So what's the easiest way for people trying to do the easy stuff?
I think request response with WebSockets it's pretty trivial in reactive. I wouldn't want to do it the other way with the old non-reactive APIs. I can try and put one in. We might have time. Let's try it. Let me think about how that would work. But basically,
I was thinking more like the example for your book, where you're going through a chat server and so on, and you end up creating a thread to arbitrate between the 2 streams and so on.
Thread between the streams. I'm having a hard time remembering offhand, but
no, I shouldn't be throwing something like that at you. Anyway, don't worry about it. But yeah, that's what one for you to think about. The other one would be one of the problems I found when I was moving from Project Reactor to things like Webflux is that with stuff like Webflux, you don't do the subscribe. The subscribe is taken care of for you. So if you could speak a little bit to that about when you do and don't, manage the subscription yourself.
Right. So first thing, speaking to that first point, I would agree that reactive APIs are more difficult than the equivalent imperative code. But if all you've ever known is functional style programming, then it's not that much more difficult. If you've imagine you're a Java programmer that started using Java with Java 8 streams, and so you've never had to use vector, you never had to use, you never really spent a lot of time dealing with array list or iterators. Instead you just use Java 8 streams and everything there. So in that light, it's actually very natural to use the reactive types. I would argue that it's quite natural to express algorithms that way. I appreciate that that's not everybody, but it's certainly possible. And for me, I had that same sort of epiphany where it's like, oh, okay, I get it, right? I just see how these things flow together. That's one thing. I disagree with the idea that it's more difficult. It's just different. That's all. It's different. And the thing is, once you've crossed that initial learning, hill there, that little bit of setback, like I say, once you've gotten that, suddenly everything you're dealing with is just publishers. So instead of having Kafka message listener containers and having RabbitMQ message listener containers and the simp messaging template for WebSockets and having a different API altogether with an SSE emitter for service and events, instead of having all these different APIs so that you can write code that arranges somehow to get your callback in the right place given an asynchronous result, rather than doing all that, you've just got publishers. It's the same for everything. So the consistency makes it much easier to keep in your head what's happening and to compose higher order things. It also gives you velocity because you can now compose these things naturally. So reactive APIs might be a little bit more complicated than the equivalent imperative code. But that said, now the other thing is Node.js these days, they have it's all callback. In 2010 when Node.js came out, it was all callback centric. And then even they got wise to how inefficient and hard that was, so they created promises. And that's basically where we are with reactive APIs. Promises are more or less equivalent to promises there. But JavaScript and C# and Python and Rust and basically every other language under the sun, except for Java, went one step further. They actually built in something into the runtime to support suspending the client thread given an asynchronous action. And you write your code in the imperative style, but when you hit a function or a method that's going to do something asynchronous, for some definition of asynchronous, when that happens, the code is rewritten in such a way that it's actually, you get to this endpoint, you launch this asynchronous thing, the compiler adds a callback to that asynchronous thing that picks up the context that you would have had the method or function executed from where you left off. So basically that callback is a continuation, and it has in scope all the variables that were in scope when you got to that line in the code. You write line 1, line 2, line 3, line 4. If line 3 ends up calling an asynchronous function, everything after line 3 is a callback to the asynchronous thing in line 3, right? You don't have to write that callback code though. The compiler does it for you. And so in every language that I know of, except for Kotlin, that's called async await, right? And so that's actually really nice, right? You can actually, that gets you the resource efficiency and the benefits of reactive APIs, while also giving you, well, some of the benefits of reactive APIs. It doesn't give you the programming model that allows you to deal with the inherent volatility of distributed systems, but it gives you the resource efficiency, and it's easy to approach. It's easy to use, and so it gives you some of the uniformity that we want. So that's nice. But in Kotlin, they call that a suspend function, not async await. But either way, that's great. I like that. I wish Java had something like that, right? It's a bit of a pity that we don't, and it doesn't look like we will anytime soon. But
you do find people trying to use the reactive APIs in a non-reactive way. So what they're actually returning is a mono of a collection of thing instead of a flux of thing. And once that gets ingrained into the code, it can be hard to iron that out.
Yep, and I'm gonna well, sometimes you need a materialized view of something, right? So the rest of the world consumes, like when you get to the JSON boundary, then you need a list as much as anything else, right? So that matters. But yeah, sometimes they're trying to shoehorn that. And by the way, the framework itself, Spring, going back to your question about who subscribes to what, because there's some indirection between what you return from a controller handler method and what gets sent back to the client, Spring is very accommodating. So if you want to return a publisher of T, it'll do the right thing. If you give it a flux or a mono of something of T, it'll do the right thing. If you give it a flowable type, from RxJava or whatever, it'll do the right thing. But if you also give it just a T, it'll do the right thing. It'll turn it into mono behind the scenes, right? Ditto for a collection of T. It's not like that stuff has stopped working. It's just it's worth bearing in mind that it's not the same API and it's not a drop-in replacement. But if you want to just take your existing code and drop it into a controller inside of Spring Webflux, who knows? Maybe most of it will work. Maybe it's not the most efficient way, but it might work. And you might be missing you might have foreclosed on the opportunity to take advantage of reactive APIs, for example, in data access, which of course, that's not going to be a drop-in replacement either. But you might get off the ground, right? It might get you your first step into the water.
Yeah, I was pleasantly surprised by that. The first time I accidentally returned like a list of T in Webflux and everything just worked, and it was like, thank you.
Love that.
And then there's some questions there in the stream. I think you can see them there for yourself, possibly.
I cannot. I see private chat, nothing, and comments.
Sorry, no worries. I can just read them off to you then. What is the description? Sorry, what is the difference between subscribe and block in Flux?
Subscribe is the one that you should be calling if you want something to execute asynchronously. So there's no guarantee on it as to which thread that'll execute the subscription. The receipt of the results will happen on whatever thread the runtime sees fit to put it on. You can influence that choice by prescribing a scheduler, but again, it's up to the scheduler, not you. Block forces it to arrive, or it forces the materialization of the result to happen on the client thread, on the calling thread. And you could actually fake that more or less by providing a scheduler there's a client thread scheduler that you can use that effectively runs it in the same thread as the calling method, right? Which has the effect of blocking, basically.
Yep. And then is it possible to communicate between blocking and non-blocking functions?
Absolutely. You can use subscribe on or publish on. So you can say, I want to execute this particular pipeline on a separate scheduler. But then you can, when you subscribe, you can get the result and you can do something with it and then say, I want to run this thing back on this other scheduler, right? And is that what you're talking about, or is it more about how to actually communicate?
I think so, hopefully. Yeah, it's a short question. Yeah.
What would you say?
Oh, yeah, no, I think that was the answer they were after. Yeah, cool.
Yeah, it's all about moving them off the right thread pool, but you can wait for the results just as much as anything else, right?
Cool. Yeah.
Okay.
Just maybe one final question there. How much to do with the adoption of reactive is to do with people waiting for the database piece to be sorted out? Because as you said at the start, there's the R2DBC stuff there now, which is great. And is that the kind of piece of the jigsaw that's been holding people back? Because that you get the maximum benefit from everything being reactive, and the database access is the last piece.
It was, but it hasn't. That hasn't been the case for a year.
Mm-hmm.
R2DBC has been GA for most of last year, if not all of it. It's been in, I don't even know when we introduced it in the Spring Boot, but you could run code that was GA for, put it this way, accepting the two little glue classes that were in Spring Boot, right? Two auto configurations in Spring Boot itself. Everything else in the stack, including the driver and the R2DBC spec and the Spring Data R2DBC project, was GA a year ago. Right? So that has been real. We announced R2DBC at Spring 1 2018. And we had been working on it for at least a year in sort of research and development before that. So it's mature. I don't know why people wouldn't adopt it yet. I can say, let's say you're using some obscure database that, we don't have a driver for, then yeah, of course. But if you're in that list, I'd go for it. R2DBC, by the way, they don't have support for stored procedures yet. So that was what they got everything that people would need except for stored procedures, stamped to GA, stabilized, got a GA, released that. And then now that the dust is settling, we've got a number of implementations and we've got different partners in the ecosystem developing their own implementations. We can stabilize and figure out what it means to build a stored procedures abstraction on top of this. So if that's your case, if you really need stored procedures, don't move to R2DBC yet.
Cool. Grant. Oh, one final one here. Could you talk about the difference between the project reactor approach and the actor system, like you would have in akka, for example?
Sure. Actors are a message box. They're a way to say that I want to communicate. They're structured. There's a different kind of structured concurrency. They're a way to say that I want to serialize requests into a thing that can do work for me, right? That's it. They're just a style of programming. They borrow from Erlang's OTP, right? The Erlang OTP mechanism had the same idea. You communicated state changes by sending messages to mailboxes in actors. And when you say actors, that implies a supervisory hierarchy of actors that actually in turn are responsible for restarting the subordinate actors that may or may not have failed. So this has a whole this design choice implies a lot of other things about your architecture that are a lot more prescriptive than reactive APIs. It implies, for example, that your actors need to be idempotent as much as possible because you need to be able to retry the same message, right? The first try may have failed. If it fails, your actor gets put out of commission or whenever something goes wrong, the supervisor hierarchy will restart the actor somewhere else and then retransmit the same message. If you do something and you have undue observable side effects in processing that second message, you're not going to like that architecture. It's going to be a hard slog, right? But actors are awesome. I love Akka. Akka is amazing. And obviously, it's the best actor system out there, bar none, right? And Akka Streams is a Reactive Streams compatible API. So Akka Streams is separate and apart from Akka. But think of Akka Streams as being kind of like their version of Reactor. And you can use Akka Streams to vend and consume publishers and so on. So you can actually use Akka Streams to do some sort of computation and then do that computation using an Akka actor system, have the result done on the Akka cluster using an actor system, either remote or local, get the computation coming back into your code, right? Just like you would with any other actor ref. And then you can send that and you can get a publisher from Akka Streams and you can send that right back to Spring Webflux. Cool. So you get really interesting opportunities there. Spring Webflux is just data flow. It's just like the Java 8 streams, but with back pressure and this protocol. So you could build Akka with reactive streams, and I dare say they probably already did, right?
Cool. Very good. Well, I thank you very much for the answers. I shall disappear again and let you continue with part 2.
Well, so do we want to give people a break, or do we want to give them 1 minute or whatever? Either way, I would like 1 minute so I can go get a coffee.
Very good. Let's, well, if we say a 3-minute break then until 9:20.
Okay, done. I'll be back.
Cool. Very good. Very good. So after an incredibly short coffee break, I shall reintroduce Josh. Josh,
Sure.
off you go.
All right, very good. Thank you so much. Let me share my screen here again. Come on, share, do the thing we practiced. Alrighty, so hopefully you can see my screen now. Now, I have my 8 records in my database. Great, right? Not a big deal, but I do have it. That said, that's not really showing, it's not really fully exploiting some of the benefits of reactive APIs, right? One of the places where reactive APIs really shine is wherever you might have otherwise dominated a thread in the non-reactive implementation, you can perhaps free up that thread in the reactive version. And this is typically true of things that are long running or long lived, right? So anything where you might need an ongoing connection would have typically corresponded for each request one to a thread, right? Well, that's problematic if the response is long lived or if it takes a long time. So what I'm going to do is I'm going to create an endpoint here called the greetings service. And the greetings service is going to return a stream of greetings responses, given a request, right? And the request is going to have a name, and the response is going to have a message. Okay, so oops, I said spelled incorrect. That's fine. Okay, good. So there's my two basic DTOs. I'm going to give them annotations to synthesize the getters, the setters, the toString, the equals, the hash code, etc. And then we're going to return a stream of greeting responses. Greetings request. Okay. And so this endpoint is just going to return a sort of long-lived stream of records. Okay, so from stream.generate new supplier. I'm just creating a stream. I'm creating a reactive stream from a Java 8 stream here. It'll just return a new one. And of course, if I just left the code as is, the results would very quickly run down the floor and out the door, and we wouldn't be able to catch up. So what I want to do is I want to stagger the results just a little bit by introducing time. And the reason I can do this is because behind the scenes, as we talked about before, there is a scheduler. That scheduler decides on which thread this stuff should run. So that scheduler, by default, creates one thread per core. So if you have 4 cores, then you have 4 threads, and each thread is an event loop, right? But it's very important, now that you understand that you do not block those threads, that you do not do work on those threads that would monopolize the threads, right? So anything that is that can use asynchronous I/O, great, you can use that. Anything that's asynchronous, right, you can use that. But if you're doing something like, I don't know, running Slack or the Fibonacci series or Bitcoin mining or any kind of cryptography, all of which is CPU bound, well, naturally, that's going to require that you stay pinned to a thread, right? These are things where, unless you've explicitly built in concurrency in that algorithm using threads, but even there, it's going to be CPU bound for bits of it, right? So that's problematic, friends. That's not going to be great. So you got to be explicit about that. You've got to be sure to subscribe on different thread pools whenever you've got work that needs to be done that might otherwise block the one of the core threads that are being used in your thread pool, right? In the default scheduler. That scheduler is 1/2 thread pool, 1/2 timepiece or clock, right? It keeps track of the movement of work from one thread to another. And as long as you don't block it, again, very, very important, then everything will be fine. But if you do block it, you're not just blocking one thread for one user out of possible hundreds of threads or whatever. You're blocking, in the case of 4 threads, 25% of your users, right? So it's critical that you avoid that mistake. And to support you in ferreting out any of these possible thread leaks, we've got this Java agent you can easily add to your application. And once installed, it'll help you detect anything you're doing on a non-blocking thread pool that blocks one of those threads. So, for example, thread.sleep is a no-no when you're trying to avoid blocking the threads that come from, for example, schedulers.parallel, right? So this is very convenient. It'll help you ferret out these problematic blocking interactions. Okay, so now I've got my service, and I've delayed it by 1 second. Each result I'm delaying by 1 second. And I also want to limit how many records I get. Let's just say 100 records, okay? Now, I could communicate. How am I going to express or expose this information to the outside world? I could create a service and event stream. I could create WebSocket streams. I could do all sorts of things, but I want to communicate this data to the outside world. HTTP is not a great fit for service communication. It certainly it's not terrible. Obviously, it is an existence proof of its ability to do the job. I'm just arguing that we could do better. And what I mean by that is for building cached documents, it's served us really well. But for anything, any use case beyond just document retrieval, it wasn't built for that, right? It's not actually supposed to be a high-performance messaging protocol. It's not actually meant to be a high-performance RPC protocol either. And so a lot of organizations have sought to get around some of those limitations that have made it less than desirable, right? Obviously, HTTP 2 is it's a big step, huge step in the right direction. But even there, even though it has improved upon some of the issues in the still currently majority deployed HTTP 1.1 or 1.x, it still has some issues. So again, HTTP 1.x has the following problems, right? Each connection has to be recreated. It's not stateful. You don't have a single connection that can be multiplexed. You have text as the payload type, so it's very porous, very inefficient over the wire. The exchange model that it supports is just request response. You make a request and you get a response. There's no such thing as true bidirectional communication. There's no support for things like message exchange patterns like fire and forget and stream in and stream out. So these are problematic as well. And so obviously HTTP 2 fixed some of those. You now have binary streams and you can have multiplexed sockets or connections rather, but the other issues are still problematic. And so you might say, well, let's use WebSockets. Well, even there you have issues. WebSockets aren't designed, again, for the kinds of messaging style service-to-service communications for which I think some of us have imagined or hoped. And one of the reasons that I would say this is that WebSockets don't support headers. Like, you're not supposed to, how are you supposed to propagate out-of-band information like a security token if you don't have a header? So this is a problem, right? What I want is some way to communicate that kind of information. It's just clearly not built into it. Obviously, in the Spring team for years, we talked about stomp.js, and that's let's see, it's an envelope object that has its own payload and headers. But it's a convention, so you have to agree upon it, and I have to agree on it as a producer and consumer. And then that, in turn, becomes the payload for the WebSocket message. So you, in order to communicate one node with another, you need to agree upon 3 levels of protocol, right? 1 is the WebSocket itself, 2 is the stomp envelope, and then 3 is the actual payload in the stomp envelope, right? It's just tedious, right? It works, but it's a bit of a hack. Wouldn't it be nice if our protocol supported all that? Wouldn't it be nice also if our protocol was natively reactive? HTTP 2 and HTTP 1x are not reactive. They don't understand back pressure, right? So for example, if I have an HTTP client, doesn't matter what it is, it could be curl, that connects to my reactive WebFlex HTTP endpoint and then suddenly disconnects, the best that I can hope for is that the reactive web runtime perceives that disconnect and then applies back pressure transitively on my behalf to all the streams that were involved in producing the response. And that is the case right now. It cancels the transitive downstream dependencies for me. But that's all it can do. It can cancel one time. Well, look at the signature of the subscription, right? You saw plain as day that there's a request method where I can request 10 records. And then in theory, because there's no prescription about time, I could just do nothing. And then an hour later or a week later, I could say, oh, yeah, I want to request another 10 records. Well, that doesn't mean I have to start over. It just means I'm requesting the second batch of 10 records, right? That's built into the Reactive Streams API, and yet it's not supported by HTTP because at the protocol level, HTTP doesn't have this concept of session resumption. Wouldn't it be nice if the protocol actually supported the Reactive Streams API? It actually supported true back pressure and it supported session resumption? That's a big deal, right? So there are other things that we can look at before we settle upon something. One thing you might look at is gRPC from Google. gRPC obviously greatly improves upon HTTP 2, but again, still there. You have to do code generation, and you've got one kind of payload, which is protobufs, right? I like protobufs, but too much of a good thing is a bad thing at some point, right? I don't want to be stuck with protobufs for everything. That feels a little inflexible, needlessly inflexible. And if good architecture is about anything, it's optionality, right? What is architecture? It's optionality. It's the ability to describe a thing that we can do later if we're willing to pay the cost now, right? So what am I prescribing? Well, I recommend something called RSocket. Now, RSocket is a binary protocol that originated at Netflix. It was developed there by engineers who then went to Facebook. So the history is a kind of a melange of the contributions from Netflix and Facebook. It was designed to be natively reactive. It was designed to get around all those limitations about which I just finished speaking. It supports true bidirectional communication. It doesn't care what protocol, or what payload you use. And actually, to be fair, it doesn't care what protocol you use either. Did you know you can actually run RSocket in the native TCP UDP sort of implementation, or on top of WebSockets, or on top of Aeron, which if you haven't heard of it, it's brilliant, absolutely amazing. So you can run RSocket on top of these other protocols if you like. It can support protobufs or Avro or message pack or Thrift or JSON or XML or whatever you want, right? That's the point. It's completely agnostic to as to what encoding you use for on the wire transport. It's also bidirectional. So once one node connects to the other, they're not client server, they're request to responder. It also has headers and so on. It's also operating root actuator management endpoints that we've been talking to Spring Boot users about since 1.0, way back in 2013. Spring Boot, not 0.6, way back in 2013. So now in the protocol itself, there's this ability to articulate the state and the health of the service, which any smart client can use for all sorts of interesting things. So what I want to do is I want to express this endpoint as an RSocket controller. So I'll just do that. I'll say at controller class greeting controller at message mapping greetings. Okay, publisher of greetings response greetings request. I'm just going to inject my service here. Private final greetings service at request args. Okay. Turn this .greet request. That's the extent of my Java code there. I'm going to now need to tell Spring Boot to create an RSocket service for me. And so I'll say RSocket server port will be 8888. And that's it. I'm just going to run the application. And I want to be able to talk to this endpoint. And there are a number of ways to do this. We're going to create a client in short order here. But I want to talk to that endpoint. And to do that, I can use this amazing tool called RSC, which was developed by my friend and colleague, the one, the only, the amazing, the inimitable Toshiaki Maki out of Tokyo. He's legendary. The guy just top shelf, amazing. So TCP, localhost 8888, and the endpoint that we're going to be messaging is called greetings, and the interaction model between the producer and the consumer is a stream. So when I talk about RSocket, it's important to understand that there are 4 different exchange types. There's request response, where one side sends a single value in, and the responder produces one value out. So one value in, one value out. There's stream, where you get one value in and a stream of responses, 1, 2, 5, a trillion, whatever responses back out. There's also channel, where you send a stream of values in and you get a stream of values back out. And there's finally fire and forget, where you send a single value in and you get nothing out, right? And this is one of my favorites, actually, because it's so useful when you think about it, to be able to say, here's some data. I don't really care if you've acknowledged it, because it's lossy, right? I don't care. It might be like logs or frame in a video or something like that, right? The system will interpolate the missing pieces if it needs to, right? Or do some sort of error correction. Or maybe it just doesn't matter, right? You don't care if you don't see every single message in certain cases, right? So it's a very nice performance optimization. So in this case, we're doing a stream. We're sending a single value in, and that value we're going to describe using content negotiation. We're going to describe a single record name. Okay. RSC, and voila, there's my stream of results that are coming back every second in perpetuity. And here, my friends, lay the magic, right? This is the core conceit of reactive programming. Yes, I've got this thread that's going to be stuck there doing whatever. How many did I say? 100? It must have been 100. I've got this thing that's going to be producing 100 results over 100 seconds. But that thread is not lost to us. In between the raindrops, in between each emitted result, that thread is freed up, and somebody else in the system can reuse it to do whatever they need to do. So we're never ever just wasting this thread. We're able to repurpose it for other things. And as we need to then emit the next value, the thread is put into service, and then the result is emitted, and then it's freed up again. So there is some context switching associated with reactive APIs, and that means that for strictly performance use cases, it may actually paradoxically be just a tiny bit slower than a simple, single-threaded transaction, right? But that's not why you use reactive APIs. It's not about making any one single transaction faster. It's about being able to handle many, 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 many times more transactions given the same hardware. So now I've got this RSecond endpoint. I want to talk to it from Java. We've just shown that you can talk to it from RSC. Let's go here and create a client, okay? And I'm going to use the Reactive Web Support, Lombok, Spring Cloud Stream, RabbitMQ. I don't need R2VC anymore. I don't need the Postgres driver. I might very well need the security support. So let's hit generate there and back up. Downloads. All right. So Spring application name equals, all right, and then we're going to say, actually, I don't care about that. I'm not going to register it with a registry. I don't need a server port. I want to make sure we I want to make sure that we free it up. Oh, did you see, friends? You know what just happened? The RabbitMQ Kubernetes operator has just reached 1.0, and I actually have been using that. It is awesome, and so I'm happy to see that. I'm going to bookmark it and make sure I follow up later. Anyway, I've got my application. I want to make sure it starts up in a random port so that I don't have to worry about port collision. And I'm going to go to my build and comment out some of the things that I don't need just yet, including AMQP. Okay, goodbye for now. Security, goodbye. Obviously, Spring Security, messaging binder, and Spring Cloud Stream. All of that can go. Okay, good stuff. So there's my application. Set up the JDK, Java 15. Now, what I want to do is I want to talk to that HTTP endpoint and the RSocket endpoint that we just created. So first thing first, I'm going to create a reactive HTTP client. And this HTTP client is a non-blocking HTTP client. I would use this even if I wasn't building an otherwise reactive application, right? Don't use the REST template anymore if you can help it. This is a much better solution. And it's pluggable. You can configure filters here for things like load balancing and so on. And with that done, I can now build a client application ready event, HTTP ready, turn event. And what I'm going to do is I'm going to inject this web client. Okay, web client. Now I want to make a call to the service. So I can say HTTP localhost 8080/reservations. And I'll get the data back. I'll say retrieve, give me the body of the JSON as the response, and I want to convert it into a stream of reservation objects. So now I'm going to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So I'm going to paste this down here and copy and paste all that and go here and voila. Okay, there's my DTOs, my client-side representation of the data. And I want to say reservation.class. And that gives me a reactive stream of reservations. Now, here, I've got a call to the downstream service. Obviously, were I using the Spring Cloud Discovery Client abstraction, I could plug in a service name like the reservation-service, and that would work. Right? Or I could do that, or I could use DNS. Obviously, if you've got Kubernetes or Cloud Foundry, they'll do DNS for you in the cluster, and that DNS is actually better than regular DNS. But it's not. There's still issues with DNS. But I'm just saying it's better than regular DNS because at least you can programmatically interrogate that DNS, and you can also use that via the Discovery Client abstraction as well. But for our purposes, ignore that for a second. Okay, let's just say we've got a call to this one host and port. What if something should go wrong? Well, first of all, I can say I want to retry. I can also say I want to retry it 10 times. I can also say I want to retry when something is true, right? And then I want to do a back off, right? I can also say if something goes wrong, I want to have an error handler. So if there's an exception, then I return an empty stream. I can control how I degrade gracefully. If something goes wrong, I can also perhaps specify a timeout. I can say I want to wait 10 seconds. Now, 10 seconds is a ridiculous eternity of an SLA. Obviously, I don't expect that you've got anything that actually takes 10 seconds. But let's do some simple math. Let's suppose that this code base here, this client, is in point of fact my API gateway. It's an edge service. It's the first port of call for requests coming in from the outside. As they arrive, I have an SLA. Let's suppose that for simple math, my SLA is 20 seconds. Again, an eternity. Lifetimes will go by, right? But 20 seconds. And that means that I need to get a response from this downstream service, this reservation service, within how long? Well, if I want to be able to retry, if I want to have any hope of being able to retry, I need to say within 10 seconds, right? So that way, if the first attempt fails, I can cut bait and try again and get a response back, hopefully within the 20-second allotment that I've got. Okay, what about the thing after this? What about the thing that, like, suppose the reservation service in turn depended on yet another service? How long would that take? Well, 5 seconds, right? Because of the same logic, right? It's we want to be able to have a timeout and then try again. And then what about the one after that? Oh my goodness, 2.5 seconds. You see the problem here? The window, the SLA, narrows more and more the further away from the origin of the request by virtue of the proximity to the origin of the request, right? And this is problematic because it's an unfair burden on downstream services because they have to meet these increasingly unreasonable SLAs. And then also, it doesn't actually help your chances all that much, right? It's still 1 out of 2, right? At best, you've got 2 shots now instead of 1. So what can you do to better your chances there? Well, there's a pattern called hedging, right? And hedging is very straightforward. It's very simple. You are going to diversify the risk portfolio, just like you do in the stock market, just like that common aphorism, don't put all your eggs in one basket. Same idea here. What I want is to launch a call, an HTTP request to 3 distinct nodes, right? The same service, otherwise identically configured, but distinct, each on a different host and port, preferably, right? And I can, of course, use the Reactive Discovery Client to do that, but I don't have it on the class back here. The Reactive Discovery Client allows me to talk to a service registry, be it Netflix, Eureka, Apache Zookeeper, HashiCorp Console, Cloud Foundry, Kubernetes, whatever, and ask it for distinct hosts and ports, and I can programmatically assure as much by deduping them, right? Then once I've got that, I want to launch a request of exactly the kind you just saw here, where I parameterize perhaps the host and the port to each of the different nodes, right? And so let's suppose that I've got a call to host 1, host 2, and host 3, right? So I've made a call to each one of them, and I want to get the results, but I want to get the fastest results. And the idea is that I'm going to discard any of these slower ones, because any of the slower ones, I don't need them. I've already got the results from the fastest one. And the result of this, of course, is, first of all, that I've ended up wasting 2 of those network calls. But remember, I'm applying back pressure. So if you're calling, these services and they're producing like 10 million records, well, the first one or 10 billion records, the first one to produce a record, that's the one that this is going to end up preserving. It'll apply back pressure to the second and third place runner-ups, right? So any of those that come back with the first record after the first record has been received by the first one, those get canceled. So even, because we can do streaming, you might not actually, yes, you've started the process of getting responses from all 3 of these hosts and ports, but you're not, if you apply back pressure quickly enough, which this operator will do for you, then you might actually end up stopping those other 2 calls in their tracks before they've gotten too far along, right? So that's the first thing. This pattern is great if you don't mind that just described inefficiency, that redundancy. And it's also great if your architecture is idempotent, if your endpoint is a bit idempotent. That is to say, if I can invoke the reservation service or whatever 3 times without any undue observable side effects, then that's great, right? But obviously, you shouldn't use this pattern for the charge the customer credit card endpoint. That's not going to be great. Don't do that. You won't make any fans. But the result is you get very, very fast code here. And so if one of these services should, for whatever reason, be out to lunch or garbage collecting or down or whatever, right? Maybe it was available in the rotation, but when you actually launched the request, it was out of the rotation, whatever. Some things can happen really quickly. You want to make sure that those failures don't drag you down, right? So this is a very natural thing to express using these patterns and primitives in a in operator in Reactor, right? Reactor is really great for scatter gather kinds of orchestration as well. So suppose I have a downstream service class. Let's say I have an interface. Okay, so I'm just imagining here, and I've got an endpoint called get orders for integer customer ID. Okay, and I want to have a DTO here. So let's class order, class customer, and this is going to be private integer ID, then it's just, there you go, private integer ID, customer ID. Okay, so I've got two types, and these could be the client representations of two types, each stemming from different microservices, different bounded contexts. And so this client of mine, this CRM client, I can imagine will provide me methods I can use to interact with these different services, the customer service over here and the order service over there, right? So lots of different services out there, and I've got one client that allows me to talk to them all. And so what I want to do is I want to aggregate them, I want to compose them in a consistent way. So imagine I've got these this kind of client, and I want to then use it. So I say, okay, class CRM client listener event listener application ready event. Like so, public void begin, and add component. And what I'm going to do, again, I'm just a prototype here. We don't actually have an implementation. It doesn't matter, but I want you to see the opportunity here. So let's say I want to aggregate the data. I want to get all the customers, and then for each of the customers in an n+1 query, which is the least desirable type, right? You would prefer, of course, to avoid the n+1 problem. But if you're going to do n+1, which is what we're doing here, then at least let the reactive APIs do it concurrently, so you can do scatter gather kinds of orchestration and composition for multiple customers at the same time. So you can get 10 customers and then launch requests for all their orders at the same time, and then do again, until you have all of it, right? So at least that's the most efficient version of this code. So now suppose I have this client, CRM client, get all customers. That's my stream of customers, and for each customer, I want to map the customer into a thing that holds both the customer and the orders for that customer, right? So this is I need to keep both in memory. I could create like a little 2-element list or something, but there's a thing called a tuple. A tuple is a typed list, so the indexed objects in the tuple have a type, a generic signature. So I will do that by using the zip operator. And the way the zip operator works, you give it two reactive streams, and it's going to take one from the left stream and one from the right stream, and emit both of these values when it has both of them as a new type. Okay, so it'll resolve the left stream and resolve the right stream, and as soon as both have produced one value, it'll emit that, join those two values in a tuple, and then the next two values, and then the next, and then the next, and it's kind of like a zipper. It goes from the left side to the right side to the left to the right, etc. Right? So here's my zip operator. I'm creating two reactive streams. One is for the customer. I'm just wrapping the customer that we just got back into a mono. And then here, I'm going to get the CRM client, and I'll get the orders for this customer ID. So I'll say customer.get ID. Okay, now that's going to give me the orders, but I want a materialized view. So I'm going to actually create a list of records here, okay? Now what do I have here? Let's clean up a little bit. So I look at this. I have actually wanted to flat map this, right? And the result I have there is a publisher, a reactive stream of tuple of customer of list of order. And now I'm home free. I want to take that result, tuple to flux, map it into a new aggregate type. And what's that aggregate type called? Customer orders, right? So customer orders, private customer, private list of orders, data. This is my aggregate type. I say new customer orders, and tuple get T1 is the customer. Tuple get T2 is the list of orders. And there, now I've got a stream of customer orders, and that's doing it in the most efficient style possible. It's not wasting any threads. We're not blocking. We're doing it. We're fanning out at the same time, getting all the results and putting together the results. So the result is that you get the responses much faster while only writing 3 lines of code. That's a win here, friends. You can use these reactive APIs to really make short work of this kind of really complex stuff. Think about that hedging implementation I showed you earlier. Think about all the painful code you'd have to write to get that right, were you not using the reactive APIs. It would be a nightmare, right? You'd be using countdown latches and cyclic pairs and threads and whatever. It's a race condition. That's not great. Trust me, friends, there's only one person who truly understands how to write multi-threaded Java code in the Java ecosystem. And it's not you. That's the important part. I don't know who it is. It's definitely not me. It doesn't matter. That's the point, right? Let the framework do it for you, right? And here's where Reactor really comes into its own. Now, obviously, this whole thing is a sketch, right? This idea of orders and customers, but I hope it's illustrative of the possibilities here. Okay, so here's my reactive stream. Let's log out that result. So let's say subscribe R, and I'm going to just print out HTTP response r.toString. Great. Okay. Now the next thing I want is a listener for. I want to call my RSocket endpoint, right? So I'll say RSocket requester. And here, the construction is fairly straightforward. Builder, return builder dot, and again, see, we would connect when the application first starts up, and we can stay connected. So localhost 8888.block, not bad, right? And I want to then use that. I can say, okay, well, I can just inject that here. Our socket requester. And here, our socket requester routes greetings data, new greetings request, bash client. Okay. And I want to get a stream of greetings responses back. And there's my RSocket stream. And here, as before, I'll subscribe system out RSocket gr toString. Okay, there we go. So there's my 2 streams. I'm going to run this code. Okay, there's my HTTP results, and there's my ever incrementing stream of RSocket responses, right? Just as before. So this gives us what we're talking about. It gives us the best of both worlds here. And you can see that I don't think I'm running RabbitMQ. And so as a result, I'm getting these error messages. Brew services, start RabbitMQ. Okay, it looks like it's good. Nope, JK. So something's clearly wrong. It doesn't matter. We're not going to use RabbitMQ. We don't have enough time. But you can see the results, right? I've got my HTTP response. I've got the greetings responses, and both just reactive APIs. I told you that I liked RSocket because it gives me flexibility here. So yes, obviously this is nice, but it's binary and it's fast and it's non-blocking. But one of the really interesting opportunities here is bi-directional communication. So let's suppose that I have a client that has some sort of state that the service, it's the implementer of the service, the producer of the data, will care about in determining whether to continue producing that data. It doesn't matter what it could be like, oh, the user has left the chat room, or there's no responses, or they've stopped watching the video, or maybe maybe there's some sort of telemetry information has indicated that they're offline, or whatever, right? It doesn't matter. The point is there's some signal from the client to the service that the service wants to be aware of. So let's simulate that here with a class client health state, okay, something like that. And I'll say healthy. And this is just going to be a Boolean. It's a thing that has a Boolean. And I'm going to create a controller here, a client health controller. And returning a stream of client health states given a request. So I'll return, I'm just going to simulate this, right? Obviously. I'm in the client. Remember, this is still the client code. New supplier, return new client health state, math.random greater than 0.5. So almost 50-50, not quite exactly, great. There you go. Almost 50-50 chance of result. Duration of 1 second. It's just a Spring Boot controller. Now, this is a controller in the client code. The thing that's making the request to the server also now can answer questions as though it were a server. And so in order for that to work, I need to tell my RSocket requester to make that endpoint available to the world, to advertise it, to mount it, to expose it, whatever. And the way you do that is by configuring this. So here, RSocket socket acceptor, and let's say return RSocket message handler dot responder, and I can inject the RSocket strategies. And when you're doing RSocket, the strategies object is the thing that Spring Boot passes around to describe encoders and all that other stuff that you care about. So it's a great thing. You might want to customize it, in which case you can use the RSocket strategies customizer callback interface, right? And that'll give you a chance to register a thing that'll be given a reference to the singleton strategies object, and then you can configure things like, oh, I don't know, authentication, right? That's very convenient. You should know about that interface, but you should also know that it's very useful to have a reference to the strategies object in various places. The other thing that we care about here is the thing that we're trying to actually expose, right? The controller that we want the world to see. So I want to inject a reference to this controller here and pass that in as a second argument. Good. So there's that. Okay, so there's my HTTP endpoint. I'm going to restart this. And, well, it's not going to work if I restart it, is it? It's going to fail because I'm going to kill this in short order. So, oh, what's the issue here? Oh, yeah, C, socket acceptor SA, acceptor SA. There you are. Okay. Okay, so now on the service side, I want to be aware of that client health information. And so I'm going to do the opposite here. I'm going to copy and paste the client object to the service here. There you go. And in my controller endpoint for the RSocket endpoint, I'm going to ask the client to give me a reference to the client socket, to the socket representing the connection with the client service, right? So that with a client connection. So where do I put that? Where's my controller? Here. So I'm going to say, okay, RSocket requester, client RSocket connection, right? And we've already got this. We've already got the stream of greetings. And I want to say client RSocket connection, give me the health, and expect the stream will be a client health state dot class. And what this is going to give me is a reactive stream. It's going to give me a reactive stream of results that are healthy or not. Well, of course, I don't care if they're healthy. I only care about when it's not healthy, because then I need to stop sending data. So I'm going to drop all but the unhealthy results. Right? So CHS is healthy. I care about the not healthy ones, right? Those are the problematic ones. So this, you could say that for most of the life of the application, this reactive stream, flux client health state should be empty. If it's not empty, then we've got a problem. And so that's the code I want to write. I want to say, okay, send back this greeting stream, but only so long as the health endpoint is empty. As soon as it emits a value, then I want to stop sending back the greeting stream, okay? So this is very easy thing to express. It's bidirectional communication, very natural in the RSocket world, very natural with reactive APIs. Okay, so the service is up. Let's go back and restart our client. Oh, what did I call it then? I created a controller, didn't I? Did I not? Where's my client health? Oh, I didn't. That was silly. Okay, there you go. So apparently my 50-50 chance. The first message came across just fine, and then the next one, the client by that point decided it was sick. It sent a message, and we stopped the stream. Right. So this is very, very cool. Right. This ability for my services to communicate bidirectionally like that, to communicate data like that, super useful, and it supports native back pressure on the wire. So imagine you're a large social network, and you've got this protocol that allows you to avoid having people using their iPhone and Android apps going into tunnels and losing connections and then re-requesting the whole stream of what they were looking at. Instead, they can just pick up from where they left off, right? That's a really interesting opportunity, huge cost center efficiencies, and it's just a more flexible protocol around. My friends, obviously, we've just begun to scratch the surface here. I hope you learned something from this. I hope you had fun from this. I hope that it was worth your time, and I hope you liked what you saw. I certainly like this stuff. I'm a big fan. Obviously, I'm wearing the Reactive Spring t-shirt. Big fan. Wrote 6 books about Spring, actually. But you don't have to take my word for it, right? There's a lot of organizations that are using this stuff to great effect at scale. So obviously, Alibaba is, I think, the one that I'm most proud of. Prior to 2020, because 2020, right? But prior to that, I used to spend a few days every year in Hangzhou, China. Maybe it's a week sometimes in Hangzhou, China, with Alibaba, just embedded with the different organizations in the portfolio of the Alibaba sort of conglomerate, right? And there's Ant Financial, Taobao, Alipay, AliExpress, Alibaba.cn, etc. All these different organizations are all Spring, and they have been for years. So I've been going there for years, right, since 2012 without fail. And I spent time. I just spent time. 2014. I remember, or 13. I went to them and said, "Look, we're doing this thing called Spring Boot. You got to try it out." And of course, then that took off like wildfire in the organization. Then Spring Cloud, then Reactive, and then RSocket. And they love RSocket so much. In addition to their commitment to Spring, that now they along with Facebook and along with the Spring team and along with a number of others, we have formed and Lightbend, we formed the Reactive Foundation, the first full-fledged project of which is RSocket, right? So the opportunities here are huge. There's a lot of organizations that are converging on this protocol, that are using it, embracing it, and so on. It's just really interesting. I mean, there's some really interesting possibilities. One possibility is having a broker, a hub. So imagine you've got a hub to which other microservices connect, and they stay connected. Once they're connected, they stay connected, and then from there, the hub can take requests from the outside world, mediating from HTTP to RSocket, and say, oh, well, this request was intended for this downstream service. And the service, because it has access to these stateful connections, can ask any one of these open connections, hey, which of you is less busy? And then forward the request to that downstream service. If there are no instances available, that hub can say to the client, hey, I'm not disconnecting you, but I'm not going to give you any responses. In effect, I'm going to apply 100% back pressure. The other benefit of that, of course, is that those microservices, those satellite microservices, they are all black box if they want it to be, right? They don't have to have any ingress whatsoever. They can open up a connection when they start up to the hub, and that's it, right? There's no way to punch in their firewall. Their IP tables are just blocked, right? Completely locked out everybody. So it's a better security posture. It's just really interesting, right? You can have a hub that kind of replaces a lot of different patterns, things like service registration and discovery. Use the hub like that. Use an RSocket broker. Things like client-side load balancing, not so much. Not sure I really need that, right? Even certain use cases for message buses kind of go away as long as you're willing to tolerate some risk profiles associated with losing data if you should lose that socket, right? So there's some really interesting opportunities implied by this hub, and this hub is a collaboration. This broker is a collaboration between a lot of us, and we've already had a few working prototypes, so I know it's possible. It's just not yet done, so that's why we didn't cover it today. I want to thank you all for your time. I hope that in addition to, I hope that you will join the ranks of organizations like Netflix, like Alibaba, like eBay, and many others besides, and see if you can find a place for this this stack in your organization. Obviously, we didn't get to talk about Reactive Spring Security, didn't get to talk about Reactive Kafka or RabbitMQ, didn't get to talk about Reactive Spring Cloud Function, right? So you can do serverless, you can do Azure Functions or AWS Lambda or all these different kinds of things with our Spring Cloud Function abstraction, which supports reactive APIs. So there's just so many other things that we didn't get a chance to look at today, but that's okay. We've always got tomorrow. Now, thank you so much for your time. I hope you're all healthy and happy, and I'm happy to answer questions at this point if there are any.
Very good. Well, we're slightly past time, so let me just throw one final question at you. If I'm using RSocket and Spring on the back end, but I have a browser-based front end, so I know that RSocket has a JavaScript implementation, but what would be the easiest way to kind of use it, within the browser?
That's it. There's a Node.js client, right? So there's a couple things to consider. First of all, it's a protocol. It's a binary protocol, so you can speak to it from Java or JavaScript or C++ or whatever. There's bindings for all sorts of different languages. That's the first bit. Second bit is the transport is pluggable, as I indicated earlier. So you can use WebSockets, right? You can use the WebSocket transport for your browser-based applications, and so on.
Cool. Very good. Excellent. Well, I think we will wrap it up there. So it only remains to say, Josh, thank you so much. That was absolutely excellent. Very good. And thank you to everybody for attending. And please keep an eye on our meetup and our Twitter, because we do have a couple of extra things planned before the end of the year. But stay tuned for further details. So, Josh, thank you so much once again. And everybody else, see you soon.
Happy holidays, by the way.